My name is Vikram Paswan and my topic is machine learning based rainfall prediction. As we all know, rainfall is important for many processes such as productivity in agriculture, growth of the animals and plants, maintaining balance in ecosystem and other such processes. So in further slides I will gonna explain about my dissertation and work which I have done. As we all know that agriculture, water management and the avoidance of natural disasters are just a few of many areas that rely on accurate rainfall predictions. Ecosystems, human lives, and agriculture are all negatively impacted by the unpredictable nature of rainfall, which may cause floods, droughts. Predicting the rainfall using machine learning models trained on historical meteorological data is the primary objective of this study. In order to find the best model for this project, I am comparing the performance of two machine learning models. First one is bagging classifier and second is voting classifier. The use of decision trees, random forest, and support vector machines, among others, to forecast rainfall. It has been the subject of several research projects. In order to predict when it will rain, so I looked at typical meteorological conditions such as temperature, humidity, pressure, and wind speed. Uh, Ensemble techniques such as bagging and boosting may enhance model accuracy. According to research, practical uses such as flood management need accurate predictions, yet balancing uneven datasets and maintaining good recall are ongoing challenges. The methodology of this project involves two key stages. First one is data pre-processing and second one is machine learning model development. First of all, the historical weather data is cleaned and processed, ensuring that missing values are handled and relevant variables are selected. Uh, then it applies to assemble machine learning techniques, uh, which are bagging classifier and voting classifier, both of which combine predictions from multiple models to improve accuracy. Each model is trained on the same dataset and evaluated based on performance metrics, which are accuracy, precision, recall, and F1 score. The ensemble machine learning models strengths in variance reduction and predictive capability led to their selection for this project. Bagging classifier creates several subsets of the training dataset, trains separate models on each, and then averages their predictions. Uh, the final forecast is determined by the majority vote in a voting classifier, which aggregates the prediction of many algorithms. Each model contributes a vote. In voting classifier, we uses two types of votings, which is soft voting and hard voting. These techniques aid in making models more stable and less prone to overfitting. So in this dissertation, I have used CRIPS-DM methodology to develop this machine learning based project on rainfall prediction. So the dataset I have taken from Kaggle, and there were 24 variables in this dataset, and the variables like location, minimum temperature, maximum temperature, wind speed, direction of wind, humidity, pressure, and fraction of clouds, and so on. The scikit-learn module in Python was used to implement the bagging and voting classifiers. Factors like air pressure, humidity, temperature, and wind speed made up the dataset, and 80% of the dataset were used for training purposes, while just 20% of the dataset was put aside for the testing models. I use the performance indicators including as accuracy, precision, recall, and F1 score to compare the models prediction with the actual outcomes after they were trained. In comparison to voting classifier, the bagging classifier model performed somewhat better so far. As you can see here, the bagging classifier achieved an accuracy of 86% and an F1 score of 0.62, indicating moderate balance between precision and recall. Precision was 0.75 and recall was 0.53, meaning the model correctly identified 53% of the actual rainfall events, while the voting classifier had slightly lower accuracy of 85% and F1 score of 0.60. Its precision was also 0.75, but its recall was 0.51. That means it identified 51% of the actual positives. Uh, that means both models were performed reasonably well, but bagging classifier performs better than voting classifier, making it the preferred model for rainfall prediction for sure. In conclusion, as you can say, predicting when it will rain is crucial for several reasons, including agriculture management and ecosystem protection, and identifying the impact of natural calamities like droughts and floods. In order to forecast future precipitations using past data, this research compared two machine learning models, which are bagging classifier and voting classifiers. When I compare to the voting classifier, the bagging classifier performed better due to its greater or high accuracy, which was 86%, and improved precision, recall, balance. Because of its outstanding performance in this work, the bagging classifier is suggested for future projects, including rainfall prediction as well. So for future directions or future researchers, predicting the precise quantity of rainfall in an area that may be explored in future study, while the importance of investigation was on the weather or rainfall would occur, expanding future datasets and adding more weather related factors, like including air density, uh, volume released, and wind direction might enhance existing models. So researchers might also investigate uh, ways to forecast how long it will rain, which would help in agriculture planning and like disaster management. Hybrid machine learning models that integrate many approaches to improve prediction accuracy and might also be investigated. in future research.